Hi there, this is Penelope. This is a video, hopefully it won't be too long a video, on some of the applications that you may come up against using the ability to solve equations. I don't expect you to do these now. I expect you to kind of cast an eye over this video and just see the sort of things that you might meet. Okay, here's one. The stress can be obtained by formula blah blah blah. Find the stress. Okay, so that means you're looking for F, so you need to rearrange it, and you do a little bit of algebra. And you would cross multiply. And then you need the F's in the right place. You need the F's together, so you would expand the brackets and then you would rearrange so that you would get and then you can factorize. You could factorize the right hand side, but it doesn't really matter. And then you've got an expression for F. Now you can put in the numbers and you would get that F. So substitute in numbers. So that F is equal to 3000. Now, I'm not an engineer. I'm not sure what the unit is there, but you will know. Okay, the next one isn't a practical example, but it is one that you may well meet. And what it requires you to do here is to make a substitution. It doesn't matter what you call it, so that it allows you to write what you've got as a quadratic. So then we can rewrite it as z squared and, oh, that's a nice one. Now remember, those are the values for x. So now we have that 2 to the x equals 2 and 2 to the x equals 8. Now you can go through the process of using the rules of logs, etc., but it's very easy to see by inspection that x must equal 1 or x equals 3, because 2 to the power of 3 is 8, 2 to the power of 1 is 2. But you could check that in the original expression. Then you know you were right. This is kind of similar, but what it needs you to recognize is that you've got, instead of 4, you've got 2 times 2, and that then you can break that up to, that's the first part, to the power of x, times 4 to the power of 1. And this left-hand bit becomes 2x to the power of 2 times 4 minus 65. 2 to the power of x equals 16, or minus 16 equals 0. Now if we make, again, a substitution, then we can say 4z squared minus 65z minus 16 equals 0. And you would need to use the quadratic formula to solve that. And you'd use your calculator. Now, we could just proceed just without thinking at the moment. And then the next step would be to use logs to say that x equals natural log 16.493 over natural log 2, or that x equals natural log negative 0.243 over natural log 2. And at that stage, you should realise that you can't take the natural log of a negative number, so that answer's gone, and that x is approximately, and you should check that. Next question about the swimming pool. Possibly if you draw a diagram, but there's a pretty good diagram there. We can just draw on that. We could make there that distance there is x, and that distance there is x, and that this distance is 5, and that this distance is 13. And then that gives us the ability to break it all up into little bits, and we can add those little bits together. So we can add this square, the square here that's not quite there, the square in that corner, the square in the other corner over there. Then each of those little squares is x by x, and this rectangle here is 5 by x, and we've got 1 at each end, so that's 2 times 5 by x. And then we've got this one, which is x wide. So we've got 13 by x, but we've got 2 of them because this one on the right hand side is 13 by x, so 2 times 13 by x. And the original question tells us that the area of that path is 78. Okay, we can rearrange all of that, tidy it up. We can say that 4x squared plus 36x minus 78 equals 0. Use your quadratic formula, and we will get that x equals negative 10.8 or 1.8-ish. Like that, approximately. Now the first answer is obviously not sensible, so the answer would be 1.8-ish, whatever the actual exact answer is, meters wide. When you're doing this kind of question, you have to think back to the rules that determine the nature of the rules, and the one that we're looking for says that a quadratic will have real roots if b squared minus 4ac is positive, so it's greater than 0. That's ax squared plus bx plus c. So what we're asked to do is that they will be real. We've got the rule, and now we just have to put in that. So it's going to be, the roots will be real if negative 2 squared minus 4 times p times 5 is greater than 0. So what have we got? 4 minus 20p is greater than 0. 4 is greater than 20p. P is less than 4 over 20. Therefore, p is less than 4 over 20 is 0.2. Now, if we look at the graph of that, this is the graph of 0.2 x squared minus, what was it, 2x plus 5. Now you can see here that this is the limit of where the roots will be real. The roots are real if it's crossing the x-axis. So if you do anything other than that, if you say p is equal to even 0.21, then the graph is above the axis like that, and then they're not real. The roots are not real. So that's what the actual meaning of that answer is there. This one, whoops, didn't change, that one there. With this kind of question, finding the equations is the hardest part. Once you've got them, it's a relatively simple matter to solve it. So you need to say, we need to give things names. So we could say let x be the shorter part, or be the length of the shorter part, and y be the length of the longer part. So then we can write out what we know. We know that x plus y equals 62. And we know also that, well, obviously we're talking about y. 2 meters less than y has got to equal 3 times x. It doesn't make sense if you do it the other way around. You end up with a sort of a gap in your logic. Now, you could do this two ways. You could do this either by elimination, or by substitution. It doesn't matter. Either way, you're going to get that x plus y equals 62. Rearranging it, I've done here 3x minus y equals -2. So 4x equals 60, x equals 15, so y equals 47, and then you should check your answer. And it works. The last question here, the trick in this last question is that you've got the information in a format that really doesn't work if you just blindly go ahead and don't think about it. What you need to think is that all the lengths are in centimetres, yet you've been given the volume in litres, so you need to change that. You need to say that the volume is 500 centimetres cubed, not 0.5. Now, the volume of a cylinder is going to be pi r squared h, and you're told that that is 500. So h, because, just pause for a second there, we've got what we're trying to prove has got no h's in it, yet if we look at the surface area for a cylinder, it will actually say 2 pi r squared, that's the bit at the bottom and the bit at the top, and then plus the circumference times h, so that would be 2 pi r h. Now, you look at what you're trying to find, there's no h, so it means that we need to find h. So h is going to be 500 over pi r squared. Now, we know what a is. It's 2 pi r squared plus 2 pi r times 500 over pi r squared. We cancel one of those and one of those, cancel that and that. So now we have 2 pi r squared plus 1000 over r. That's what we were asked to prove. Okay, we did it right. Okay, thanks for watching.